According to German experts from the University of Dortmund, it is possible to distinguish 6 project principles on which scenarios for the implementation of Industry 4.0 are based. Interoperability. Interoperability refers to the ability of objects, machines, and people in a business to communicate, exchange data, and coordinate activities. This ability to connect everything in a company, everywhere and with everyone, is essential to take advantage of the insights provided by data to increase efficiency and improve processes. Implementing and embracing new technology has only limited capacity if the product or system cannot exchange contextual information with other products and systems. Similarly, interaction between machines and humans remains limited to simple and defined cases without interoperability. Interoperability cannot happen without connectivity, so as a first step, businesses must digitize their operations by utilizing cloud computing for software programs and data storage. The next step is to start integrating open-source platforms and software. Open architectures, which are designed to be flexible and adaptable, can support the integration of different technologies and systems and can facilitate interoperability. Virtualization. Virtualization refers to 2 different scenarios. One virtual resource is created from multiple physical resources, and second one, many virtual resources are created from one or more physical resources. In the first scenario, the hardware environment of a business is simulated by creating digital twins of physical assets using data from sensors. In the second scenario, software is used to divide one physical server into multiple virtual servers that act like unique physical devices. Digital twins, or 3D models, are used to optimize machine performance, allowing what-if scenarios to be run and the impact of new equipment to be tested. They can also act as companions for physical objects for operators to view the real-time status of the machine, analyze performance, test solutions, and identify potential issues before they arise. This can help you extend the life of your business' physical assets, uncover operation inefficiencies, reduce maintenance costs, and understand your equipment better. For industries that don't rely on large equipment and machines, such as aged care and education, virtualization can be used to reduce hardware costs and the number of physical resources needed. With virtualization, applications, desktops, servers, and data are no longer dependent on one physical device, improving reliability and enabling add-ons to be included when required. Decentralization. Decentralization is the process of transferring power and decision-making authority from a central authority to smaller, more local entities. Decentralization is something that businesses have been embracing for years, moving systems to components rather than a central computer to enable unlimited scalability and flexibility. Some key areas where decentralization is likely to be important in the fourth industrial revolution include distributed ledger technologies, such as blockchain, peer-to-peer networks, autonomous systems, such as autonomous vehicles and drones, which can operate and make decisions independently, decentralized governance models, such as those used in blockchain-based systems. Real-time capability. Real-time capability refers to the ability of a system or process to operate in real time, meaning that it is able to process and respond to data and events as they occur, rather than with a delay. In the fourth industrial revolution, real-time capability is likely to be a key enabler of the convergence and integration of multiple technologies and will be critical to the development of more intelligent and responsive systems. This enables you to see what's happening in your business, what can be improved, and where productivity opportunities lie. It also allows you to analyze micro-trends, immediately respond to failures in production lines or take a proactive approach to anomalies or inefficiencies. Thanks to the proliferation of sensors and internet-connected devices, most businesses already have access to large amounts of real-time data. The challenge lies in processing and analyzing the data so that business operations can be continuously optimized. This is where open-source tools are critical, allowing small and medium-sized enterprises, SMEs, to build an inexpensive and integrated reporting platform for insights across multiple data sources. Cloud computing means this information can be managed in real time without the need to wait for reports, with many services offering embedded analytics that can be viewed anywhere and at any time. Service orientation. Service orientation is the design and delivery of products and services with a focus on meeting the needs and expectations of customers. In the fourth industrial revolution, service orientation will be important for the development and adoption of new technologies and systems. Some strategies for promoting service orientation include customer-centric design, designing products and services with customer needs and preferences in mind, using customer feedback and research and integrating customer insights into the design process. Personalization. Delivering personalized products and services tailored to individual customer needs and preferences, using data and analytics to understand customer needs and preferences and advanced technologies like artificial intelligence to personalize the customer experience. Omni-channel delivery. Offering products and services through a variety of channels, including in person, online, and via mobile devices, to make it convenient for customers to access what they need. Continuous improvement. Focusing on continuous improvement and ongoing development of products and services to meet changing customer needs and expectations, using customer feedback and research and data and analytics to identify improvement opportunities. Modularity. Modularity refers to the degree to which a system or product can be divided into smaller, independent components or modules that can be easily assembled, disassembled, and replaced. In the fourth industrial revolution, modularity is likely to be an important factor in the development and adoption of new technologies and systems, as it can enable the development of more flexible and adaptable systems and can support the integration of different technologies and systems. Some key benefits of modularity include flexibility, being able to adapt to changing needs and requirements, as individual modules can be added, removed, or replaced as needed. This can enable organizations to respond to changing market conditions and customer needs. Scalability. Modular systems and products can be easily scaled up or down to meet changing needs and requirements. This can enable organizations to respond to changing demand and to optimize the use of resources. Interoperability. Easy integration with other technologies and systems, as individual modules can be easily connected and disconnected. This can support the development of more flexible and adaptable systems and can facilitate the integration of different technologies and systems. Maintainability. Easier maintenance and repair, as individual modules can be easily replaced or repaired without the need to replace the entire system. This can reduce maintenance costs and downtime.